स्टार्ट करें सर? आप लोगों को मेरी आवाज आ रही है? कैन यू गाइस हियर मी?
Yes, sir.
Okay. So it's about 9:50, so we are going to start the class.
Okay, sir.
In detail, like what are the different equations and what are the different values or distances we have to stick to while designing a connection. So this is an example, like this is example 7.1. Okay, now it requires you to check the board spacing, and it requires you to check the edge distance and the bearing for the connection shown in figure 7.1. Okay, now this is the connection. Okay, so this connection is made of two plates. Okay, this is 3 by 1 is 3 by 8 inches, and this upper plate is member is about 3 by, where is that thickness? This is 3 by 8, and this is about I have to see what is the thickness mentioned here. Thickness of this plate, yes, 1 by 2. Okay, so you can see that. Let me grab my pen. Yes, the thickness of this gusset plate, or we call it gusset plate. Okay, this thickness is 3 by 8 inches, and thickness of this plate is half inches. Okay, so there are two type of loads. Okay, dead load and live load, which is acting over the connection. Okay, now the spacing of the boards have been given, like the edge distance is given, the center to center between the bolt is given, this distance is given. Okay, now we have to check the board spacing first, and we know that board spacing is like we have to use this guideline in order to check the bolt spacing. Okay, now what is the diameter of the bolt? The diameter of bolt is 3 by 4 inches. So if you have calculator, can you kindly calculate this value? This is about 3 by 4 inches. What is this value? This is 2 inches. Okay, so as per the code requirement, the distance between center to center of the board should be at least 2 inches. Now we have to compare it with the actual spacing. So what is the actual spacing? Actual spacing is 2.5 inches. 2.5 inches is greater than this requirement. Okay, so this is fine. Center to center spacing is fine. Now we have to check the actual edge distance. Okay, no, actual edge distance is from center of this bolt to this edge, and the given distance is 1 by 4 inches. Actually it is asking for this LE value, and for LE value for a bolt of 3-inch diameter, the minimum edge distance is given. The minimum edge distance is, you have to go to this and you have to see which bolts we are using. We are using 3 by 4 inches bolt, and for this the minimum LE is 1 inch. Okay, LE is 1 inch. Okay, and the distance is, given distance is like in the figure is, which is less than the given distance 1 by 4, like this one. So this is okay. Remember, you have to check this distance, and you also have to check this distance as well. This distance as well. This distance you have to check, and this distance you have to check. Both you have to evaluate. In this case, they are the same. So LE requirement is okay, you see. Now you have to evaluate the bearing strength of the connection. So for bearing strength, we have this type of formulation. This formulation is recommended to check the bearing strength, LC. Okay, this is T into FU. LC we have to calculate. Okay, now center to center distance is given, and we have to calculate LC here, and we have to calculate LC here as well. So in order to calculate LC, how we can calculate LC? LC we can calculate by LE minus diameter of hole, half diameter of the hole, because LE is from centroid to this edge. Okay, now hole is actually more than the diameter of the bolt. Okay, actually there is an allowance, like for example the bolt diameter is 3 by 4 inches, so the hole is always made 1 by 8 inches more. Okay, so in this case we are just taking it half of 1 by 8. Okay, the hole diameter is the diameter of the bolt plus 1 by 16 inches allowance, and that comes out to be 13 by 16. So you have to subtract this to get this LC value. Once you have LC value, what you can do, that you can use this equation, this simple equation. So we have 1.2 here. LC is about 0.8438. Thickness is half inches. Okay, and FU for 836 steel, because it is made of 836 steel, it's about 58. So it comes out to be 29.36 ksi. Remember, this equation has an upper limit, so you also have to check that upper limit as well. And what is that? 2.4 dtfu. This value should not be greater than this value. Okay, this value should be less than this. Okay, so how we check that? So you go there, you check that limit on Rn. So this comes out to be 52.2 kips. So 29.36 kips is less than 52.2 kips. Okay, so this is okay. Now Rn is bearing strength of the bolt per bolt. Okay, and how many bolts we have? We have 2 bolts, so we have to multiply it with 2. Okay, now as I told you that in this connection we have 2 plates. Thickness of this plate is different than this plate, so we have to check the same thing, or the same round of calculation we have to go through it for this thickness as well. Okay, and then we have to see whichever is minimum, that will be the controlling load or bearing strength. Okay, now as I told you that first we have to check the bearing strength here, then we have to check here. Now we have to check here. So we know the center to center spacing S, and we know the hole diameter. Half plus half makes 1. So this is 1.688 inches. Okay, now you have to use the same formulation again. This LC is different, so you have to check. This comes out to be 58.74 kips per bolt. Now you have to evaluate the upper limit. The upper limit is 52.20. Okay, now the upper limit is it is less, so it is greater than this limit, so it cannot exceed this value, so we will stick to this value. Let me write here. If this 2 bolts here, yes, yes, and yes. Strength over here is Rn 29.36 kips per bolt. Okay, these for these two bolts. Okay, over here we also have to evaluate the Rn, bearing strength. This comes out to be 52.20 kip per bolt. Now this is done. This we have evaluated the bearing strength. We have checked the minimum edge distances. Okay. Now the same procedure we have to use now. Okay. The total bearing strength of the tension member is two. This two. This is these two bolts. Okay. By this strength, like. And 2 multiplied by this strength. Okay, this is total bearing strength of the bolts. This is 29.36 plus 2 multiplied by 52. Now the thickness of the gusset plate to which it is connected, or the second part of the plate of the connection. Sorry, what happened? Am I connected?
Yes, sir.
Okay, am I connected? Okay. I'm sorry. Now we have to follow the same procedure for the gusset plate. Okay, let me grab my pen. This is the pen. So we have to evaluate the same procedure for the gusset plate. Okay, the gusset plate have the same whole dimension for same as this member. Okay, only thing is the thickness is different. So you have to go through the spacing will be the same, but you have to evaluate the bearing strength only. In the bearing strength, if you see in the bearing strength, I hope I'm not making it very boring for you people. Rn is equal to 1.2 LC T. You see T? The bearing pressure that it will be exerting on the gusset plate will be different than it is what it is exerting on the tension member. So you have to check the same thing. You have to calculate the Rn value. So for gusset plate, the total bearing strength, which is a bearing strength which is of the bolts, is 122.3 kips, and for the tension member, it came out to be 163. Okay, so what do you think? What will be the controlling value of bearing strength of bolts in this case?
163.
No, 122. This will reach first. Okay, before you reach 163.1 kip. Before you reach this value, you will reach this value. So this is the design strength, bearing strength. Okay, so this is controlling. In this case, the gusset plate is controlling. Okay, okay. Now if we want to calculate the bearing strength according to the, or based on LRFT, we have to just multiply it with the resistance factor, and this resistance factor in bearing strength case comes out to be this one, 0.75. So we have to multiply this design strength is 0.75 into 122.3 kips. So it comes out to be 91 point, what is that value? 91.7 kip. Okay.
7.
Yes. Now you have to compare this with RU. What is RU? RU, we have dead load, we have live load. You use this combination. Actually, you have to use multiple combination concerning dead load and live load, but this will be the controlling one. Okay, so this value comes out to be 90 kip. So design bearing strength of this connection, which is made of this tension and gusset plate, is greater, or it should be equal to RU. This RU is 90 kips here, and this design strength is 91. So this is valid. So if you want to calculate the bearing strength of this connection based on AST procedure, you simply don't have to use this phi. Okay. So what you have to use factor of safety. And this factor of safety in ASD, factor of safeties are represented by this omega sign. This means factor of safety. And for bearing strength for connections, this factor of safety is 2. What you have to do is that you have to calculate the allowable strength, and you divide by nominal strength by this factor of safety. What is the nominal strength? 122.3. So you divide it by 2, you will get this one. Now you have to compare it with the applied load or required strength. So we don't use these load factors in ASD. You remember we discussed it in the second class that we don't use these load factors. Okay. So what you do, you have to just add the magnitudes of dead and live loads, and they are given 15 kip, 45 kip. Okay. Now you just add these two and you will get 60. Now this should be less than the allowable strength. Okay, in the case of AST, allowable strength should be greater than required strength. So allowable strength is 62.1 and this one is 60. Okay, so this is okay. Okay, the bearing strength of this connection, spacing requirement, edge distance requirement are satisfied according to AISC recommendation. The things you should remember whenever you are evaluating the bearing strength of a connection, you should use phi 0.75 in LRFD, okay? And ASD, for bearing strength, you will use this is equal to 2. Note it down in your journals or note it down in your notebooks, okay? Now, do you have any question?
No, sir.
Okay. So now I have added, okay, we can proceed to shear strength of the bolts, okay? But before going to that, I couldn't finish this part with the last class as well, okay? So I asked them before going to shear strength, so they can go to this problem number 7.31. And I can give you some time and you can go through this problem by yourself. So I will give you about 10 minutes or so. Go through this problem, please. इसको करें अभी. I can give you some hints. Now, in this case, A36 steel is not used, okay? But we have A242. And you will be asking, okay, what is the FU for A242? For A242, the ultimate strength of the material is 70 KSI, okay? This tension member, this is a plate, the thickness is different. What do you think that which will be controlling, this member or this member? Like the bearing strength of the connection, which will be the controlling, in the gusset plate or in this tension member?
Gusset plate.
Because it has less thickness. So now you become more wiser. So what you are going to do, for this gusset plate only. You will perform this check for this plate, not for this. Okay, because the material is same. This is A242. This is A4242. If these were two different materials, so then there was a problem. Then you have to evaluate both. Okay. Now center to center distance is given. This LE is given. Okay. LE is given. Okay. And you have to use, this time you have to use 7 by inch diameter bolts. Okay. Now you have to check the spacing, edge distance requirement, and the bearing strength, nominal bearing strength. Okay. So you have, I think, 10 minutes. Okay. आप लोग करें इसे, ठीक है? कोई प्रॉब्लम हो तो मुझसे पूछें. This one and this one. Okay, you should attempt this one.
Sir, I think we should proceed with that lesson. We can solve it later on.
But can we wait for 5 minutes? Let other people do it, okay?
Okay, sir.
Just try it yourself. It's very easy. It will give you some confidence. What is the minimum spacing you have calculated? What is the value of minimum spacing? S is 2.33 inches as per the code requirement. LE is 1.5 inch. This is the requirement of the code. Okay. H is 15 by 16 inches. This LC is 1.031 inches. Okay. Now this LC is, I will term it LC2.
So spacing is turned out to be 2.625. 625.
Which formula you have used?
Sir, 2 by 3 into dB into 3.
Okay. Now it comes out to be 2.33 inches.
Sir, 2.625.
Okay. 2.625. Actually, 2 by 3 into 2, it comes out to be 2.67. And if you multiply it with the 7 by 8, so it should be 2.33.
Yes, sir, 2.33. Sorry, I was doing it
Okay.
3 times dB.
Okay. But you can also use this spacing as well, 3D. Okay. LE की क्या वैल्यू आ रही है?
सर एल का फार्मूला है एल सी माइनस एच.
किसका फार्मूला कह रहे हैं आप?
सर ये एल एल ई का सर.
LE देखें, LE you have to go to the table. This table.
Okay.
What is the diameter of the bolt?
7 by 8.
Okay.
1.125.
Yes. ठीक है, ये वैल्यू भी आपकी ठीक है. Okay, I think the time is up now. RN for this case over here to this side, the controlling bearing strength is 32.48 kips, and in between you have Rn, which is 55.12 kip. Okay, so there are two problems. Okay, this one I have asked you to do it in the class. This one you can do it by yourself. Okay, if you have any problem you can ask me. Okay, please remember that in quizzes, in examinations, so the problems can be one of these problems. Okay, not only the examples we will give away in the paper quizzes, we can give these problems as well. So it is important to solve these problems. Okay.
Okay, sir.
Yes. How many of you have, what is your name? Sir, what's your name?
Sir Amir Khan.
Amir Khan, you did that, you have completed this problem? Almost, up to some extent.
Yes, sir. Yes, sir. To some extent.
Okay, what about other students in the class? How many of you have completed or you have started doing it other than Amir? और कोई है जिसने अटेम्प्ट किया ये क्लास, ये प्रॉब्लम? ये आप लोग सो रहे हैं? आर यू स्लीपिंग?
No, sir.
ये प्रॉब्लम अटेम्प्ट किया आपने? अच्छा, अहमद, you didn't do it, but please do it. Okay.
Okay, sir.
Ahmed Mohammed, you are from?
I'm from Sudan.
Okay, did you attempt this problem?
No, sir, because I came late in this class. There is no electricity here. So I will come to later on.
Okay. Okay. No, we will move on now. We will move on now. Okay. Now we finished that. What are the minimum requirements on the edge distance, center to center spacing, and how we can evaluate the bearing strength of a connection? Okay. Now the next step is the shear strength of the bolts. Okay. The shear strength of the bolts can be easily computed by this formulation. Okay. Rn is equal to AB by these shear stresses. Okay. Now, as I told you, there are two type of bolts: unfinished bolts and high strength bolts. And high strength bolts, I told you, they will be designated as group A or group B. And group A representative high strength bolts is this number, this bolt. And group B designated high strength bolt is A490. Okay. If you are using A307, the shear strength you can evaluate using this formulation. For example, in your connection, if you have this, okay, if you are using A304, the shear strength of a single bolt is 27 AB. Okay, AB is the area of the bolt. Okay, this area can be pi d square by 4, or this can be AB pi d square by 2. Okay, when we use this area and when we will use this formula, when we will use this formulation, this area, when we will use, ये कब इस्तेमाल करेंगे और ये कब इस्तेमाल करेंगे?
सर सिंगल और
एक बट ज्वाइंट है.
Yes, नहीं बट हाँ वो भी ठीक है, that is correct as well. This is double shear. Okay, this is single shear. ठीक है, सिंगल शेयर में आपका क्या आता है? लैप जॉइंट. ठीक है, लैप जॉइंट, बट जॉइंट. Okay, now if the thread is in the plane of shear, so you will use this formulation in order to compute the shear strength of the bolt. Okay, this means A 2, 3, 5 bolts, high strength bolts. Okay, if thread is not in the plane of shear, so you will use this formulation. Okay, when threads are in chain player, you will use this. If when the threads are not in chain player, you will use this. For A90, so threads are in the plane of shear, so shear strength is reduced. If the thread is not in the shear, then you will use this formulation. So this is basically how you compute the shear strength of bolts, which include unfinished bolts and high strength bolts. Okay, remember this table. Is that clear to all of you?
यस सर ये ग्रुप ए और ग्रुप बी जो है ये A307 के हैं कि नहीं, ये अलग हैं A307
और भी आते हैं, लेकिन इन ग्रुप ए मींस मोस्टली A325. A325 is representative of group A, high strength bolt, and A490 is representative of group B.
ठीक है सर बस.
ठीक है, you just have to use this table. Okay, now we have to go through this example now. Okay, how much time is left? So I will go, I will go over it quickly, but in the next class we will again go over it. Okay, now basically you have to determine the strength of the connection shown in figure 7.1 based on the bearing, and now they have included the shear for the following bolts. For unfinished bolt A307. Okay, now what you have to do, you have to calculate the bearing strength. Okay, using what is the diameter of the bolt? The diameter of the bolt is 3 by 4 inches, and first we will evaluate this for A307 bolts, ordinary bolts. Okay, so what you have to do, you have to compute the bearing strength. Okay, now the bearing strength, we know how we can calculate it. You have to calculate the LC, you have to know the thickness, and you have to know the material. They are made from A36 steel. Okay, A36 steel, we have FU 58 KSI. Okay, so similarly, similar to last problems, you can go through it. The procedure is similar. So you have to compute the shear bearing strength of the bolts. So bearing strength come out to be 28.55 per this bolt. There are two bolts. Now you have to calculate bearing strength for this bolt. So for this, you have 39.15. What will be the total strength of this connection? There is one bolt at the edge. There is one bolt. This one? Yes. So this comes out to be how much? Let me check. Yes. Okay, so this is not mentioned, but you can calculate the total bearing strength. Okay, total bearing strength. Okay, now you have to calculate the shear strength of the bolt. Okay, now in shear strength there are two possibilities. For example, it is subjected to single shear. Okay, now we have this shear strength formulation. This is shear strength. So you can go to that table, and for example, you are doing it for A307. For A307, the shear strength, nominal shear strength of a bolt is 27 area of the bolt. Okay, so you calculate the area, and this area is pi d square by 4, and this is subjected to single shear. Okay, so you calculate shear strength. This is 11.93. Now we have two bolts in this connection. You just add them together. Okay, so the total shear strength of this connection for A307 bolt is this much. Now you have to calculate the design shear strength. Okay, using LRFT, you will use again the same phi. Phi in this case is 0.75. For bearing case, this is still 0.75. This is phi 1. This is, let's say, phi 2. This was for the bearing. This was for the shear. This is the same. Now the factor of safety concerning ASD is the same. Okay, this one. Now the rest we will continue in the coming class. Is that okay?
Yes, sir.
Yes, sir.
Okay, now we will come to question and answer. Okay, now you can ask questions if you have.
Not as such, sir. It's beautiful. It's almost, sir, easy.
Okay, okay. Let me ask you that, for example, in rivets, how clamping forces are applied? What is the mechanism?
सर प्री हीटिंग होती है, फिर उसके बाद उसको कूल डाउन किया जाता है एक एंड पे, जिससे वो shrink कर जाए.
Basically, shrinkage and the amount of steel. If in rivet you have more steel, more shrinkage will be there. Okay, the clamping force is a function of shrinkage and amount of steel. And what is the steel which is being used to make these rivets? A502. Okay. What are the two different types of bolted connection?
Sir, lap joint, butt
No,
joint.
sorry, no, bolted connections. Bolted connections. What
Sir,
are
unfinished
two?
and high strength bolt.
No. Slip critical connections and bearing type connections.
Yes, sir. Yes, sir.
Okay. Which is more preferable joint? Lap joint or butt joint?
Butt joint.
Sir, butt joint.
Okay. Which bolts you will prefer to use for your bolted connection? High strength bolt or unfinished bolts?
Sir, high strength.
Why?
Sir, because they provide more clamping forces, so the friction forces. So because of the friction forces, sir, they will not need to be the slip joint phenomena,
Slip
sir. उसमें नहीं है.
Okay.
Slip connection, yes.
Okay, you should correct me if I'm wrong. Is a slip critical bolted connection becomes a bearing type connections after the slippage occur? Is this statement correct or incorrect?
Yes, sir, correct.
Sir, it is totally correct.
Okay, okay, okay. What else? Okay, if the shear plane passes through the thread of the bolt, what do you think? The shear strength of the bolt will be reduced, or it will stay the same?
Reduced.
It will be reduced. Okay. For example, if there is a double shear case in a bolt and there is a single shear case for the same bolt, which will have more strength?
Double
Shear
shear.
strength.
Double shear, sir.
Why?
Sir, the cross section area double हो जाता है.
Yes, 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 yes. If you understood these things, okay, so doing problem, you can do it, okay. So these concepts you should carry, you should have these concepts after this class. So this is what I wanted to communicate. So if you, आप लोगों को clear है जो मैं पढ़ा रहा हूँ कि नहीं? There is a problem.